All right, here we go, studio producer.
Okay.
Hey, good evening, everybody. I'm Derrick Pitts, Chief Astronomer at the Franklin Institute, your cool astronomer, welcoming you back for the March edition of Night Skies at Home. This is episode 21, believe it or not. Thank you for joining us this evening. If you haven't been with us before, you're in for a treat. This astronomy program is a program that will help you learn how to find your way around the night skies, familiarize you with a number of new astronomy and space exploration activities taking place out there in the world. And we'll also have a wonderful opportunity to chat with an astrochemist who will share with us her experiences becoming an astrochemist, as well as help us understand what astrochemistry really means. Lots of other things along those lines. Of course, we're also looking for your questions about astronomy and space exploration. So if you'll give us a few minutes while some more people join on board with us, we'll get started with our program in just a moment. But again, my name is Derrick Pitts, Chief Astronomer at the Franklin Institute Science Museum. Your cool astronomer. You can find me on Twitter at Cool Astronomer is my handle. Feel free to send me questions there or reach out to me with any items of interest that you have. And you can also look for me there as I give updates on various things related to astronomy and space exploration. So tonight we're going to be looking at the night skies of March. This is an auspicious time of year for lots of reasons, as you well know. And we'll talk about some of those as we talk about the timing of things that are happening astronomically speaking, seasonally that is. And at the same time, we'll also talk about what objects are visible in the evening sky, what constellations are there for you to see, how you can go about finding them, what planets are available for you to see as well, and generally, how you can find your way along to becoming really, really good at finding your way around the night sky. You know, it's nowhere near as difficult as sometimes people make it out to be. And in this manner, the way that we're going to do this with you tonight, hopefully you'll be able to take advantage of the coming warm evenings so you can get out and reconnect with the universe. It'll be your opportunity to take a breather, take a step back, relax a little bit, and find a little serenity under the night sky as you look around for the constellations that are visible at this time of the year. There are plenty of bright stars out there that you can easily identify, and so we're going to use those as a way to help get you around the night sky. So thanks for joining up with us this evening. Night Skies at Home is a regular program that we've been doing over the last year since the since the pandemic began. But this is actually a home extension of a program that we've done at the Franklin Institute for quite a long time called Night Skies at the Observatory. At the Franklin Institute Observatory in downtown Center City, Philadelphia. For those of you that are joining us from outside of Philadelphia, we have a rooftop observatory, and every month we've conducted this really wonderful program that combines all of the elements we have at Franklin Institute, astronomy and space science related, so that we can provide a wonderful, authentic science experience for you under the night skies in Center City, Philadelphia, using the telescopes we have available. So up on the rooftop, we have this really wonderful 10-inch refracting telescope that is perfectly sized for working in Center City, Philadelphia, to show you bright stars, bright planets, and other objects that are available. And we also have a roof deck on the 5th floor that we use, in which we put out additional telescopes, portable instruments, also of just the right size for use in a Center City environment, so that we can show you lots of other targets as well. We mix that with planetarium programming, as well as other ancillary activities and programs to make a really wonderful, enjoyable evening for everybody in the family. So once the pandemic is over and we can all get back together at the Institute again, we'll have an opportunity to bring you in for that. In the meantime, though, this program allows us to keep our connection with you and keep our connection with the night sky. So Night Skies at Home, March 2021. Thanks for joining us. Okay, let's get started. So what we're going to do just to begin with is two things. Number one, remind you that we're looking for your questions. So send us your questions, put them in the chat box. And my technical producer on the far side, Katie, hi Katie, thanks a lot for your help. We'll feed those questions to my studio producer here, my lovely wife, Linda. Hi, Linda, say hi to everybody.
Hi, everybody.
Yeah, okay, she's there, good. And we'll take your questions and we'll answer as many of them during the program as we can. If we don't get to your question, I will personally answer your question through Facebook afterwards. So please send those questions in. We'd love to hear from you. Also, Look, here we are. We're still in the pandemic, and although there are several vaccines that are really making inroads and getting people inoculated, we still need to wear masks. Don't forget that. You guys know what to do. Our main line of defense against COVID-19 is wearing a mask, washing your hands, and maintaining that 6-foot social distancing. Sure, it may be tough, but it's a lot easier than what can happen. So let's keep that in mind, that wearing a mask is really important. This is what the science tells us to do, and the science helps us get through this, and so that's what we're going to do. So don't forget that. Okay, so let's get on with what's happening in the evening sky. Let me just mention a couple of other things. You know, earlier in the season, I talked about looking at the telescopes that you may have gotten as Christmas gifts or holiday gifts to help you work your way through each and every part of that. I decided that the better thing to do would be to put all that together in one program. So I'm going to do that next month in April, and the whole program will be dedicated to your telescope, how it works, what you can see, and how you can better understand it, okay? So we'll put that together for next month, and we'll ask you to come with your questions about your telescope and maybe what issues or problems you've been having with your telescope already. We'll try to get those worked out for you. On this day in 1979, the Voyager 1 spacecraft, on its way out toward the edges of our solar system, took photographs of Jupiter's ring for the first time. Before 1979, we did not know that Jupiter had a ring. In fact, it's not visible from Earth. It's only visible as you look back towards the sun from out in that region of our solar system. So we discovered that Jupiter has a very, very thin and tenuous ring. You can look this up online through any search engine and find out the details about Jupiter having a ring, and joins the other planets of our solar system that have rings as well. Fun to learn about. As I mentioned, don't let me forget your questions. That's right. Okay, so where are you listening to? Where are you listening to this program from? If you're from around the region, let us know. If you're from someplace else, please let us know. We'd love to find out how far our listeners are. And tonight, the special region of the United States, the southeastern United States. You know, we occasionally reach up into New England or reach out to the west or any place else. But if you're in the southeastern portion of the U.S., down towards Florida or any place else down there, let us know where you are. We'd love to know. You know, there's a great winter star party that happens in Florida every year. Didn't take place this year, but I know it'll take place next year, called the Winter Star Party. And that star party is very, very well attended. It's one of the biggest ones in the country, one of the biggest ones of the year. Not happening this year, but my point is there are dark skies around everywhere in the southeast as well. So let us know what you see from where you live. I'd also like to send out special greetings to my niece. Hey, RA, happy birthday. It was your birthday yesterday, and this program, of course, is just for you. Actually today, so happy birthday. Hope you're with us tonight, and we'll chat with you a little bit later. Okay, so now, sky phenomenon for the month, folks. Let's get into that. Right now, sunset is at 6:27 p.m. 6:27, that's pretty good. It's getting later and later all the time, of course, as we move toward the next season that's coming. I'm sorry, let me do that again. Sunrise is at 6:27 a.m. I don't know why I always get those two confused, but sunrise is at 6:27 a.m. 6:27, getting earlier all the time. About a month ago, it was at 7:20. 7:20, back in January it was 7:20 in the morning. Now it's 6:27 in the morning. We have quite a bit of ways to go before we get to our earliest sunrise. That will be coming right around summertime. But sunset right now is at 5:57 p.m., just before 6 p.m. And of course, that sunset will be coming later and later and later. One of the things that will help facilitate that later sunset is coming up on March 14th. That's the point when we turn our clocks ahead 1 hour at 2 o'clock in the morning. So that's coming up pretty quickly on March the 14th. That's immediately followed by, of course, what? The vernal equinox. First day of spring comes on March 20th this year, and it starts at 5:37 in the morning. That's when we arrive at vernal equinox. Now, vernal equinox, this is one of those interesting things about astronomy and the Earth's position in space that I love to describe. This is an instant in time when the Earth reaches a particular point in its orbit around the sun. Now, that instant comes at 5:37 a.m. on March 20th. Now, since the Earth is in constant motion around the sun, it's not as if the Earth slides to this point, stops, and waits. No, it continues on its orbital path around the sun. But at that particular point, the rotational axis of the Earth will be in such a position as to appear to be vertical, right? So we know that the Earth's rotational axis is actually tilted 23.5 degrees away from vertical, but because of its orientation at that time, it will have an orientation that allows it to give us 12 hours of day, 12 hours of dark, right at that time. So we'll be right in the middle between the two extremes of the first day of winter and the first day of summer. So this is one of those 2 points, and the vernal equinox is one of those. The other one is the autumnal equinox. Uh, when we get that nice split between an equal number of hours of daylight and darkness. So from that point on, of course, we'll be gaining more hours of daylight during the day. Sunrise is coming earlier, sunsets coming later, and of course, you know what that means, warming temperatures. Isn't that great? So we have great stuff to look for this month. We have planets, we have constellations that we're going to look for. The constellations that we're going to see in the sky right now range all the way from autumn constellations. We can still see Pegasus over on the western sky as the sky is darkening. But right in the center of the sky, 8, 9 o'clock in the evening, we have the winter circle of constellations. And this is a really, really wonderful group of stars to use to find our way around the sky, or as a beginning set of constellations to find our way around the sky, because the stars, for the most part, are quite prominent. They're arranged really nicely around a major centerpiece constellation, that's Orion, and we can easily go around the circle around Orion and identify these constellations. And the constellations are also a mix between zodiac constellations, some of which you would know quite well, Taurus, Gemini, for example, those, as well as several other constellations that have notable members, like Canis Major, for example, the big dog, Canis Major. The brightest star in that group is called Sirius, and Sirius is the brightest star in the northern sky. Yes, the brightest star in the northern sky is found in the winter sky. Now, it's not the closest star to us. That's another star that's only visible from the southern hemisphere. This one is right behind it, the second closest star to us. And this one happens to be the brightest star in our sky, Sirius. So you can easily identify that. If you can find Sirius, you can use that as a key to the others. And I'm going to use that to help us find our way around the sky. The planets that are visible, well, it's kind of tough right now. Mars is the only one in the evening sky. There are a few planets in the pre-dawn sky right now, but they're quite close to sunrise. So that's going to make it difficult for us to see them. But we'll talk about them as we get around to that portion of our program. And we will use star maps to help us find our way around. We're also going to talk a little bit this evening about Mars Perseverance 2020 rover on Mars. I've got some great images to show you about that. And we're also going to take a few moments to talk about yesterday's SpaceX Starship test flight. I don't know if you saw any of the video of that, but it was really spectacular. But there's a very key point that we have to get to in understanding what happened yesterday with that flight. So we'll talk about that and what it means for future flights or test flights of this prototype spacecraft going forward. Okay, so we have a lot to do this evening. I'm sure it'll be a lot of fun. We're looking for your questions. Let's see if we have any questions. Let's just take a few questions at this point, and then it'll be time for the next portion of our program. Okay, any questions, Linda?
Stuart from Pennsylvania would like to know, what are some of the best deep sky objects to view?
Stuart. Hi, Stuart. Thanks for checking in tonight. You wanted to know what are some of the best deep sky objects to view. Well, there are several that I can think of right off the top of my head in the sky at this time of this year that I would recommend. And one of them is the Andromeda Galaxy. The Andromeda Galaxy is a spiral galaxy, very much like our own. And this galaxy is located in the constellation Andromeda, which is connected to the Great Square of Pegasus. Now, the cool thing about this particular galaxy is that it's the closest spiral galaxy to us. Now, because it happens to be the closest, it means that, and because of its position relative to us, it turns out that this is an object that we can see with the unaided eye, no telescope needed, under clear, dark skies. You need clear, dark skies to see this unaided. Under any other circumstances, a pair of binoculars will help. And you can certainly use those binoculars under dark skies as well. But that's the cool thing about this spiral. And it is the only spiral galaxy that we can see like that. So that's a really cool one to see. The other really nifty thing about this is that it's 2.9 million light years away from us, almost 3 million light years away from us. Now, what does that mean? Well, what it really means is that as we see light coming from that object, this is the most distant object that we can see naked eye. So that's a really cool feature about that galaxy. That's really wonderful. So that's one deep sky object. Another deep sky object is found in the constellation Orion. So on Orion's belt, or hanging from Orion's belt, and we'll see this later as we look at the star constellations, a sword hangs from his belt, or a string of stars that resembles a sword. Well, among those three stars hanging from his belt, the second one is a nebula. It's the Orion Nebula, a cloud of gas and dust, in this case, where new stars are being born. You can also see that with the unaided eye, but a telescope will really help to enhance it, and under the right conditions, using the right magnification, you can actually see four brand new hot stars right in the center of this nebula. So those are two really cool ones, Stephen, that you can check out. And there are a number of other ones around the sky, and a good star map will show you where they are. Let's take one more question.
7-year-old Serafina from California would like to know, when the COVID is over, will you still continue to stream your fantastic program live?
Hello, Serafina, 7-year-old Serafina from California. How are you? Thank you for joining us. So glad you could be with us.
Sacramento.
From Sacramento, even. Yes, wonderful. We've been to Sacramento. It's a nice place. Your question is, are we going to continue to do this once the COVID pandemic is over? Will we continue to stream these programs live? I'm so glad you could be with us. And the answer to that is yes, we are going to continue to do these programs live. There's so much really great information that I think you should know or have access to, or I'd like to point you to so you can have really wonderful experiences under the night sky. We're going to keep this going for quite a bit after the pandemic is done. So thanks for joining us. Stay with us. Okay, on to the next part of our program. So tonight we have a really wonderful guest for you this evening. You know, I have been learning a tremendous amount um, about how budding astronomers, people interested in astronomy and astrophysics, have been working their way into the industry. And you know, one of the things that's always been challenging about high-level sciences and astronomy and physics in particular is that there haven't been very many people of color in this field. Now, science for a very long time, for as long as we've known, has had all sorts of biases against having people of color and women in particular gaining high-level degrees, gaining PhD degrees, and doing fabulous research, and really being shown as people who are involved in this science as much as men are. And the really difficult part about that is, you know, that discrimination is tough enough. But the other part about it is that women have been contributing to astronomy in major ways, all the way along as we've been discovering new things about the universe and coming to new understandings about the universe. There are several principles and processes that women have been responsible for bringing to the science and understanding that we haven't been learning about. But as we expand and widen the horizons for bringing everybody under the tent of astronomical research, we've been bringing additional talent to the field that helps push the field forward. So this month, in honor of women in science, tonight I have a really special guest. Ayanna Jones is a PhD student in the Department of Chemistry at Emory University, where she studies the chemical dynamics of the rhizosphere and how this chemistry can provide a window into how plants and microbes have evolved. She's going to help us understand what a rhizosphere is, I hope. Ayanna is also a graduate intern at the NASA Jet Propulsion Laboratory in Pasadena, California, where she studies how the rhizosphere impacts global elemental cycling. At NASA, Ayanna is assisting in creating a next generation Earth systems model to help researchers better understand climate change. On her way to her current studies, she studied at Clark Atlanta University, the University of Wisconsin at Madison, at Stanford, and at the University of Chicago. Her master's in Earth and Atmospheric Sciences is from the Georgia Institute of Technology. Now, outside the lab, Ayanna is passionate about increasing representation in STEM and providing students resources to do so. She is currently president of the Emory Black Graduate Student Association and co-founder and vice president of #Black in Chem, a global initiative aimed at increasing and connecting chemists within the African diaspora. You know, it's really a great pleasure for me to welcome this fabulous woman of color to our program this evening. Please join me in welcoming Ayanna Jones to our program.
Hello.
Good evening, Ayanna.
Good evening.
Thank you so very much for being with us. We greatly appreciate you taking time to join us this evening.
Thank you. It's such a pleasure to be here.
Great, great, great. So, Ayanna, you know, we had a chance to talk a little bit earlier about the topics that we're going to talk about tonight. So I just have a series of questions I'm going to ask you, and I really want to make sure that you have an opportunity to help our audience understand how you come to this science and what you hope what you bring to the science will help to open doors for other women of color to join the sciences as well. So I'm going to get started with the first question that I'm sure you've heard a zillion times. But here's what I want to do. Let's start here. Tell us about your current endeavors. What are you up to at this time right now?
Yes, so I'm up to a couple of things, 3 main projects currently. I'll start with the first one. As you mentioned, I'm studying the rhizosphere, including microbial chemistry and microbial impacts on plants within the rhizosphere. The rhizosphere is a zone of soil around plant roots. And so I grow plants within my lab and I extract the particular quinone, a substance that we know to be exuded from these plant roots. And from there, I examine how that quinone interacts with various microbial communities and the implications of what that could mean in terms of agricultural impacts and climate change. The second project that I just started on, which I'm really excited about, is looking at peptide chemistry and using my knowledge of the redox chemistry that's happening within the rhizosphere to create an external metabolism, which will be useful in terms of looking at possible ways in which life can evolve. And so if we can create an external metabolism outside of what we know to be true, what else can we create? And what is that telling us about possible ways in which life can evolve? The third project is what you mentioned as well at NASA JPL, and I am an intern. I just got my internship renewed. And so right now we're looking at how to examine nutrient cycling and elemental cycling in reference to the rhizosphere and what that could mean in terms of climate change.
Wow, that all sounds fantastic. That's great. I wonder how you have enough time to do anything.
Yeah, it's a lot.
So now the next question I have to ask you, of course, is, where did your interest in science begin, and how did you come to be interested in the rhizosphere as a focus of your studies?
Yeah, so it's interesting, when I was in high school, I was really good at physics. I remember really enjoying physics, and I was really good in chemistry. But it's funny because I actually wanted to be a graphic designer, and it wasn't until I got a full ride at Crayola University. I said, you know what, let me just go ahead and choose chemistry. Why not? And here I am. And so at Crayola, I had the opportunity to intern at the places that you mentioned, including Stanford and UChicago. At Stanford, I was able to combine chemistry with environmental science. It's actually similar to what I do now. And at UChicago, I studied astrophysics. And so I really, really enjoyed understanding astrophysics. And I really wanted to combine my love of chemistry and my love of astronomy and astrophysics. And so that's where my interest in astrochem came. And so I have my master's from Georgia Tech in space and plasma physics, in which I looked at chemistry on the surface of Europa, which is a moon of Jupiter. And from there at Emory, I decided, you know what, I really want a chemistry focus. I miss chemistry so much. And so I had the opportunity to join the lab of David Lynn, in which I am now studying rhizospheric chemistry, which is allowing me to combine my love of chemistry and my passion for applying chemistry to environmental processes.
Wow, very cool. That sounds great. Now, of course, this being an astronomy program, I have to ask you, we have to connect the dots a little bit more. Absolutely, for our audience, yes. But I totally understand that. So tell me about your interest in astrochemistry, and especially about how this affects how we think about looking for life elsewhere in the solar system and around the universe?
Yeah, so I think astrochemistry is so amazing. One, because it allows us to look at a space at a more molecular level. You know, typically when we think about space, we think about, you know, big dynamics and moving parts. But, you know, space is also the minute, very small intricacies that is the chemistry. And I think that the chemistry makes these big dynamics happen. And so I think that's what really inspires me, and also the mystery of it all as well, because, you know, there's so much that we don't know. You know, the laws that we have on Earth may not apply to what we are examining in these far-reaching places. And so that's what inspires me with astrochem. And particularly, I'm also kind of dabbling in astrobiology as well. And so I'm really excited to use what I'm learning about the external metabolism and learning about what the rhizosphere to apply to possible microbial communities in space.
Wow, exciting. That's great. Now tell me, how do you think, how do you want to apply all that you're doing, all this work that you're doing right now? Um, how do you think you'd like to apply that going forward? I mean, like, what's your destination, your ultimate goal of what you'd like to end up doing once you've completed your PhD studies and you're off and running in the research world?
Yes, I think that's a great question. I'm always asking myself that. As of now, I'm really, really interested in working for the government, working for NASA. That would be ideal. And also kind of working my way up into a more administrative role, possibly doing, of course, project development, space mission development as well. I've also really garnered a passion for science policy. And so I've had the opportunity when I was at Georgia Tech to, you know, go to DC and advocate on behalf of different agencies. And I really, really enjoyed the lobbying effect and really being able to represent an organization and something I'm passionate about. And so that's also an interest. A third interest I've had is more on the entrepreneurial space and really taking what I've learned thus far and applying it to ways in which I could contribute to industry as well in a very unique way. So those three things, there's a lot of things, but I'm really passionate about what I do and I'm really excited. This is just the beginning. So it's a lot to think about, but I'm really excited.
Well, that's really interesting that you have these sort of three distinct things that you like to do. And, you know, the second one that you mentioned about lobbying for space efforts is kind of a departure. I rarely hear anyone that's, you know, interested in bench science or working bench science, interested in making that switch over to doing lobbying in Washington. But that's a really important piece of this. You know,
Yeah.
I was in a discussion last week with some people mentioning the fact that if, as we say, no bucks, no Buck Rogers. If you don't have the money to do what you want to do, you can't do it. So
Absolutely.
that's a really important piece of that. So, and your entrepreneur idea, sure, that's a wonderful way to get into things. Also, when you said entrepreneurship connected with everything else you said, I thought, I wonder if she's going to say she's planning on opening some sort of a mining resource on an asteroid or something like that.
Maybe, you never know. You know, I personally, and back to the lobbying point, I also want to mention the fact that it's not necessarily just lobbying for, of course, space agencies, but also for people of color as well, within to increase representation as well. And I'm really passionate about that, as you can see by my involvement in the Black Graduate Student Association, as well as Black in Chem. But I'm really passionate about increasing representation in these fields because, you know, there's so much talent that I feel like we don't get to see. And so I really want that to show through.
So tell me, let's talk a little bit about that. Let's just jump into that for a minute. Well, actually, let's talk about that for a few minutes. You know, as I mentioned earlier, women in the sciences have had a difficult way to go and have rarely been given the accolades that are due. And for women of color, that's doubly difficult. Have you seen challenges as you've been making your way through the sciences?
Absolutely. There's so many things that I see and have witnessed and gone through on my journey to where I am now. And I think that, you know, experiencing those things, I think that it's to me, it's so obvious as to why there's so few. particularly of people of color, and then furthermore, Black people, and then furthermore, you bring up on the third aspect of being a Black woman. And so I think that all those things are at play. And there's so many stigmas I feel like Black women have to, battle against in the workplace, and not just in the workplace, but particularly in STEM and fields that historically have been lacking Black women and the expertise and the perspectives of Black women. And I think that sadly, what a lot of people fail to realize is that it would behoove them to have more Black women, Black people, people of color within their vicinity, because we can all contribute in ways that are so unique to the particular projects that we're working on, for sure.
Yeah, I think that's a really important point. Diversity is, one of the reasons why diversity is important is because it brings different ideas and it brings different approaches that may not have been considered before. And as you say, unique ways of approaching things that can help move any kind of project along. So I agree with you that that's critically important. So tell us a little bit more about the work that you've been doing and the work that you've been doing to try to change the landscape to provide opportunities for Black women in higher education. You've done some of this work as as we talked about just a moment ago. Tell us more about that.
Yes, there's a couple of projects I really want to shout out on this platform. One project that I've been involved with a friend of mine, Linnell Williams at Harvard. She helped to create she is the creator of the Women of Color Project, which I've been a co-facilitator of. And the Women of Color Project is a project in which we take women from underrepresented groups who are interested in physics and provide ways in which for them to learn the landscape of how to apply to these PhD programs or graduate programs to be successful, and a way to kind of prevent any leakage in terms of the pipeline, so that they can get the degree and be in these spaces and contribute effectively. So I've really enjoyed that. I've also, I'm co-founder and current vice president of Black in Chem. Black in Chem is an organization that was co-founded by a couple other Black women within chemistry at various levels. And what we do is we seek to advocate and increase networking amongst Black chemists within the African diaspora globally, as well as provide opportunities for allies to support us in those endeavors as well. And so we have the second week of August every year is Black in Chem Week. And so look out for that. If you're interested in learning more, you can visit our website, blackinchem.com. But we are definitely all about increasing representation and increasing awareness of the talent that Black chemists have, because unfortunately, a lot of times we don't get the recognition that we deserve. And so why not create our own platform to do so? Another thing that I've been involved in, I'm also president of the Black Graduate Student Association on Emory's campus. And that has been an amazing opportunity. I was vice president last year. But I really enjoy being president. Unfortunately, it's been a little bit different, being that, we're on Zoom all the time and having to find programming around that.
Right. Yeah.
But, it has been a really great opportunity for me just to engage with other students on campus and kind of get out of, the Department of Chemistry and really, impact other students' lives positively in regards to programming around Blackness and increasing awareness of issues affecting Black students on campus. And then also, lastly, I've recently been involved in the planning of the Novache National Convention. So I'm actually representing Black in Chem on that front, and we're currently planning that effort now. So I'm really excited.
And Novache is?
The National Organization for Black Chemists and Chemical Engineers. Yes, we are planning for the conference now, and I'm really, really excited about that.
So one of the things that you mentioned about increasing visibility for Black women in science and Black women in chemistry, Ayanna, is it me, or it seems as if the number of Black women in astronomy, astrophysics, astrochemistry is really expanding. I mean, I had this great, I've met you, I had this great opportunity to meet you, and I've met one or two of your colleagues. But it seems to me as if there's a fairly large group of Black women who are involved in astronomy, astrophysics, and astrochemistry. Am I wrong about that, or am I
You're
seeing things,
absolutely
or
right.
is there this explosion happening?
Yes, and it's actually very inspiring. I'm so excited to see Black women leading the way. And typically, historically, we tend to do that. But it is something to see and notice. Another question is, personally, I would like to see also more Black men in
Hmm.
these fields as well.
Hmm.
But we are definitely coming into these fields more often, and I think it's a beautiful thing, and I think that we should help encourage that more, especially amongst younger Black women as well, who may not, see Black women interested in physics or passionate about chemistry or passionate about space. There's a lot of us out there, but unfortunately, um, Black women, Black men, we do get discouraged at a very young age for cultural reasons, societal reasons, et cetera. But I think programming like this, seeing you, it's super inspiring. And I hope that other young Black students, other young students of color can be inspired that they can also do this too.
All right, so take a moment to just tell us what you believe needs to be done to change the landscape and provide more opportunities for people of color in the higher level sciences. I'm particularly interested in understanding what we can do to help younger students that are, in junior high school or high school.
Yeah, so a couple of things. Particularly, I'll answer the first part in regards to higher education. I think that, really purposely seeking out Black students is important. I think a lot of times, yes, we are people of color. Yes, this is important. And yes, we are minoritized people. But I think that unfortunately, those terms get thrown around and we end up missing Black Black people within that.
Yes.
And
Hmm.
and also, the typical argument is that we can't find students that are interested, or there's
Yes.
not students that are
Hmm.
um, capable or have the background. But that's not true at all. The problem is that they're not there's not a thorough search, in my opinion, and there's not a thorough attempt at trying to get these students are out there and they're willing.
Hmm.
But also, institutions need to think about ways in which they can be accommodating to these students. There are societal barriers, there are financial barriers, there are different things that some students cannot do while others can.
Hmm.
And so I think those need to be considered. Also, I would like to see more institutions hiring Black faculty. I think that's another thing. I think that it would be really nice to see, for me, at least at my level, to see other Black chemists, physicists, astronomers in these positions as PIs, leading research labs. I
Hmm.
think that is also really important that they are also in the room. The
Hmm.
third thing I'm going to say is to give us a seat at the table. I think that there's nothing wrong with us being in the room and contributing, and
Hmm.
also respecting what we have to say. For younger students, I would say it's important, particularly for parents, to encourage them in their community, to encourage them and not discourage them from pursuing harder, subjects like physics and chemistry within STEM. Period. I think sometimes, as kids, we're told that that's too hard, or that's
Hmm.
that's you
Hmm.
know that's not for us, or that's
Right.
that's not, culturally, we I've heard that narrative, and that's not true at all. And so I think encouraging young students to do this, and that they can do this, is really important. And also, yeah, I would say that's what I would have to say.
No, that's okay. That's great. That's really wonderful. Thank you so much for that. So, speaking of that in particular, did you have role models?
I did. Particularly going to HBCU was
Hmm.
an amazing opportunity. That was my first time seeing or having Black chemistry professors.
Hmm. Yes.
Besides that, I would say I really appreciate my mom encouraging me, and
Mhm.
and really, I remember being a young girl and her bringing home these little like kits so you can do science in the kitchen. That was super encouraging. I've always been very inquisitive, and I really appreciate my mom for fostering that further within me. And so, yeah, I think just, parental encouragement. And I also have people within my family that have PhDs now. that was also really encouraging. And so be able to ask them different questions is really helpful.
Yeah, that's really wonderful. That's great. I think that's so important. One of the messages that I always try to get out is that, if you can see it, you can be it. And I think
Mhm.
that it's really important for children of color, particularly Black children, to see the possibilities of what they can aspire to. And so the more visibility that, can be provided for people like you and your colleagues, the more inspiring it can be for Black girls of color, young Black girls of color, to consider careers in the STEM fields. So that's really great. Ayanna, are you willing to take a couple of questions?
Yeah, no problem.
Sure. Okay, I'm going to ask Linda, what do we have for questions?
Kevin would like to know what kind of information can be gathered about atmospheres around extrasolar planets and how do you gather it?
What kind of information can be gathered around extrasolar planets, and how can you gather it? That's from Kevin, Ayanna.
Well, yes, Kevin, that's a great question. There's a couple ways. So a couple things you can gather. So if you're looking at atmospheres, you may want to gather chemical information in regards to composition of their atmospheres. And that can give you different information, such as if it's maybe habitable based off what we know about habitability. And you can probably do that by using a satellite. Or eventually, I know NASA's planning a couple missions, for instance, the Europa Clipper mission, by sending an actual spacecraft to the actual planet or moon and extracting data that way.
That's great. I know you must have some excitement about the Mars
Yeah.
Perseverance rover, right?
Yes, it's really exciting.
Yeah.
Absolutely.
I was actually in a discussion earlier today with some folks about if you recall a few months ago, maybe it was last fall, there was a big hubbub about the identity of the molecule phosphine in the
Oh, yes.
atmosphere of Venus, and
Yes.
I'm sure that really must have been interesting for you as well.
Yeah, it was extremely interesting. I was definitely watching the dialogue back and forth about that. And Venus is definitely a planet that we're really interested in. And I think the discovery of phosphine particularly made that more interesting for people.
And just for everybody else, if you didn't catch this, folks, as this was happening last fall, the identity of phosphine in the atmosphere of Venus was for some an indicator of the possibility of some form of life in layers of the Venusian atmosphere that hadn't been detected before. And the reason why is because phosphine is one of those molecules that's something that would be excreted by some kind of form of life. So, in many ways, it's like a microorganism fart, if you will, if you'll excuse me. But this is one of the tracers that can be used for life elsewhere. There are a lot of studies that are looking at this. And one of the things that has to happen, I learned today, actually, Ayanna, is that what scientists have to do is they have to be able to eliminate every other possible way in which phosphine could be produced in order to tie it directly to a life process. So I know that's an interesting aspect of the work that you do, is trying to separate these things out and understand them. I think we have another question too.
Estrella, she says, as a woman of color, do you ever experience imposter syndrome? And what a fabulous journey you are on. You've accomplished so much. And she's an inspiration to her daughter, Serafina, who we heard from earlier, 7-year-old Serafina.
I don't know if you could
Oh,
hear that. Could you hear that?
yeah.
Yeah. Yeah.
Yeah, that was beautiful.
Yeah.
Um, so yeah, I'm sorry, what was the first part of the question? I'm enamored by the second part.
No, that's okay.
As a woman of color, do you
Yes.
ever experience imposter
Okay.
syndrome?
Yes, so absolutely, I'm human. There's times where I think like, man, I am in this space. But I actually thought about this earlier today. I was meeting with my NASA committee, and I was the only woman, the only Black woman in this group of, white men, which is fine. But I thought, I deserve to be here. Why not? And I think when I get that imposter syndrome, I definitely just ask the question on the other side of why wouldn't I deserve to be here?
Yeah.
So that helps
Yeah.
me.
That is really important, and that's a great thing to recognize and identify. Many of us have that kind of situation going on. I'm not immune to that myself, so You know, we do have to ask that question, why shouldn't I be here? So that's a really
Exactly.
great response. Thank you. Is there another one, Hen?
Yes, indeed there is. And this one comes from Ben. He would like for Ayanna to speak more about the Drake equation relating to life on other planets.
Oh yeah, we didn't get to ask you that question,
Yes.
Ayanna. So you could have heard this about, can you talk a little bit about the Drake equation and the possibility of life
Yes.
elsewhere? And of course, you know, we can't let you go without asking you what you think about the possibility of extraterrestrial life. And, you know, at the very end, we'll be really cheesy and ask you if you think any extraterrestrials have visited us.
Okay, yes. So the Drake equation is an equation in which scientists will use to determine if life is possible within space. And so, do I think that we have life in space?
Well,
I do,
mhm.
but I don't think it's like I think it may be like microbial life, but not anything in terms of um, complex life like you and I. I don't think
Mm.
maybe that is there. I don't know, but I will say I definitely know that there are microbes within that may be living on the different planets and things.
Yeah, yeah, that's the very interesting part of the work that's being done at Mars,
Yes.
to possibly identify microbial, essentially fossils of microbial life from the early history of Mars. But can we go back to one thing I think you said before when we talked about Europa?
Mhm.
Um can you talk a little bit about your interest in what the possibilities are for life at Europa?
Yes, so Europa is unique because Europa is, of course, the moon of Jupiter, but it has an ocean beneath its surface. And so scientists are really interested in what could be within this ocean. And we know that the ocean is unique because we know that there must be some type of heating going on in Europa's interior. And so we know that, there's actually more water within Europa's oceans than are on Earth's within Earth. And so we know how complex, Earth's oceans are. There's so much that we don't know about what's in our own ocean. So perhaps what could be within Europa's oceans. And so at Georgia Tech, I was looking at surface chemistry on Europa. And of course, there's the Europa Clipper mission that is coming up. And that is definitely going to be looking at ways in which the possibility of what could be within Europa's ocean. So it's super exciting. I'm excited for Europa Clipper. That's my favorite moon. But
I totally
we'll
understand
see.
why.
Yeah.
Yeah, that's one that I really like to point to for people because of the similarity between the deep ocean environments here on Earth and the
Yes.
possibility of the deep ocean environments there at
Mhm.
Europa. So that's really cool. Ayanna, I want to say thank you very much for joining us. This has really been
Absolutely.
fascinating, and I'm so pleased that you were willing to take some time to be with us this evening to help us understand a little bit more about your journey to becoming a scientist. Of course, we wish you the best in your journey, and I hope you'd be willing to come back and join us again in the future and tell us a
Yes.
little bit more about what you're doing.
Thank you so much. I would love to do that. And I'm so, excited to have been on here. And I hope that you guys, continue to do this.
Thank you so much. So keep up the good work, and
Thank you.
all you can do to help encourage young girls, young Black girls, to become scientists, of course, will
Yes.
help to make things better. And good luck with all the work you're doing.
She's getting
Thanks.
shout outs.
Okay, thank you. You're getting shout outs here, by the
Oh,
way.
wow.
So wait, in Minneapolis, New York City,
Minneapolis, New
Oh,
York.
wow.
New Jersey,
Mm-hmm.
Florida,
Mm-hmm.
Seattle, Ontario, Canada,
Wow.
North Carolina, and Vermont. You go, Ayanna.
There you go.
Thank you so much. Bye.
Okay. Thanks again for joining us. We'll talk to you again soon. Well, folks, I hope you enjoyed that portion of our program. We learned a tremendous amount of really important information about women in science, Black women in science, and particularly the work that's being done in astrochemistry, astrobiology. Ayanna is a fantastic example of what's coming in the future for the expansion of science among people of color, particularly women of color. Black women are really moving forward in this science. I can't say, it's hard for me to tell you how excited I am about that. But it's a really great role model for young kids coming up. So again, big thanks to Ayanna for joining us this evening, and we hope we can have her back again with us in the not too distant future. Okay, so we have other things that we're doing for our program this evening, folks. So let's get on with it. So what's coming up next for us is we're going to talk about what's available to be seen in the evening sky right now. We're going to take a look at some star maps that help us that'll help us find our way around the sky, and a few other things along those lines, along with the planets that are available. I did mention when we were talking before, we had a couple of questions about deep sky objects that might be visible, and I'll point those out too as we take a look at the night sky maps. So what I'm going to do right now, folks, is I'm going to share my screen. If you'll hang on, I'll get over to my screen right over here. Let's see if I can find it. Here we are right here. Okay, great. So I'm going to minimize this portion of the Zoom chat. And hopefully now, folks, you can see what you should see is you should see the opening page of the Mars 2020 Perseverance rover mission. Hopefully you can all see that. But we're going to shift gears from that. And I'm going to go out to one of my star maps that I like to use online here. This is a Stellarium Web Online that I'm going to shift over to here. And hopefully you can see that. And what I've done is I've expanded the screen so we can all see things here. I'm going to do a little bit of adjusting here right now just to open up the screen a little bit for you. And hopefully you can see my cursor here. Stellarium-web.org, you can see up here in my URL bar, shows a night sky that you can manipulate around. It's like a home planetarium, if you will, that allows you to find your way around the sky. And you can see right now, it just looks like dots on the sky with a few objects named. And if you follow my cursor, I'll come down to the bottom of the screen where you'll see the letter N for north. And then below that are icons of the different options you have for adding things to the screen to help you find your way around. Well, one of the things I'm going to do is I'm going to rotate us around in the sky by clicking and dragging. And as I pull us around, I'm going to pull us around so that we're facing south. The reason why I'm setting us up like this is because as you're out observing underneath the night sky, if you face the direction south, what you will have done is to set yourself up to follow how the sky seems to pass by as you're outside observing. Objects appear to rise in the east, pass overhead, or pass through the south, and set in the west. This is obvious as we see the sun's apparent motion during the day. It rises in the east, passes through the south, and sets in the west. So if you're out observing just like this, facing south, you'll have the same setup, and that will work out quite well for you. So now, as you can see in our sky, there are quite a few stars that are available to be seen. And one of the first things that you should take a look for is for the planet Mars. Now, Mars, as you can see, is high in the west-southwestern sky, and it has a nice rosy color that you can see. But Mars right now is very close or nearby to another red object in the star that I'm circling right here. This is the bright star of the constellation Taurus called Aldebaran. So the constellation is Taurus. The star is Aldebaran. So one of the other things I can do, of course, with this is I can zoom us in a little bit so that we can get a bit closer to the stars in the sky. That's all I've done is I've zoomed us in. And now you can see here's Aldebaran. And these stars are the face of the bull, Taurus. And not too far away, over a little bit to the west, you'll find Mars. Now, the difference between the two objects will help you in understanding how planets appear differently from stars. So as you're looking into the evening sky, and you look up and you can identify two red objects, one of them will be twinkling. The twinkling one is the star Aldebaran. The reddish object or pinkish object that's not twinkling, that's the planet Mars. And so this follows sort of a guiding principle about observing the two objects in the sky, and that is stars twinkle, but planets don't. That's generally speaking, stars twinkle, but planets don't. So as you go outside to look up into the sky, you see these two objects. You'll see two pinkish, orangish, reddish objects. You'll try to figure out which one is which. The one that isn't twinkling is the planet Mars. And as you look at Mars, don't forget, there's a new rover sitting on the surface. We'll talk about that in just a few minutes. But please notice that Mars is very, very close to this circled group of stars here that we know of as the Pleiades, the seven sisters. This is a cluster of very young, very hot stars, not very old at all, just a few million years old. And there are many, many more stars in this cluster that we can't see. But as you observe it, it will look like a little tiny dipper. It has seven stars, all clustered together in this little tiny portion of space, and it will look like a little tiny dipper. So even under center city skies, you should be able to pick this out without too much difficulty. And of course, Mars will be right next door, so you'll be able to identify that without much difficulty. So I'm going to back us out a little bit more now and just bring us out to a fuller sky, because I want to show you the other objects that are available around the sky. So I mentioned Taurus and Mars right up here in this portion. So what I'll do is I'm going to add some constellation shapes so you can see them. But before I do that, I just want to let you know that constellation shapes as we see them in the sky is very much like a giant connect the dots game. That's all it really is you're just connecting dots of objects in the sky. Now there's a set of dots a set of connections that we use that we identify as constellations. And this is a group that we've all come to agree we will use as representative as these particular groups of stars. And in that way, when I talk about the constellation Orion, and you think about what Orion is, we're talking about the same thing, okay? So it's what's called a convention. A convention is what has been set up to identify these particular stars. So here are the star outlines or constellation outlines that we know of for major constellations in our evening sky. So right up here, we find Taurus, and we can see where Aldebaran is, just across from Mars here. But if we come back a little bit toward the south, we come to the central object of the winter circle of stars, and that's Orion the Hunter. You can see Orion right here is shaped like a person with three stars that mark the waist of the person, two stars above that line that show the shoulders of Orion, and then down here we see a knee and an ankle of Orion here at these stars. Now these stars, of course, have these really great names: Betelgeuse, Bellatrix, Rigel, and this one over here is called Saiph. It's not shown here. If I zoom in a little bit closer, it'll show up, but Betelgeuse, Bellatrix, Rigel, and Saiph. One of the cool things about Orion is that it has this really large red giant star we call Betelgeuse. As it turns out, Aldebaran is also a red giant star. So there are two easy examples of red giant stars that we can see in the evening sky right now. On the opposite end of the temperature spectrum is Rigel down here at the lower portion of Orion. Rigel is a very, very hot bluish white star that's really burning its energy quite quickly and is rather young relative to Betelgeuse. Betelgeuse is much cooler in temperature, and that's the reason why it has this reddish color. Its temperature is down to about 6,000 degrees Fahrenheit, whereas Rigel is a star that has a temperature that's up in the perhaps 15 to 17,000 degrees surface temperature. So it's much, much hotter, and for that reason glows with this bluish, slightly bluish, but mostly white color. Now, the other cool thing about Orion is just below Orion's belt, we see these three stars in what's called the lower sword. And of those three stars, it's the center one that is the Orion Nebula. And you can see, hopefully, as I've blown this up, that you can see right in the middle here, there's this sort of cloudy, misty material that make up the nebula. And this is the gas and dust from which new stars are being created. So this is a stellar nursery, a place where stars are being born. This is one of the few places, if not the only place, that we can see without optical aid with our naked eye where stars are being born. And of course, if we use very powerful telescopes, we can see all sorts of great images of what the interior of the nebula looks like. So I'm going to back out now just so we can see the larger landscape of stars and constellations that are visible at this time of year. Thank you for your patience as I've zoomed back and forth. Let's do that winter circle now so that we can see all of the stars of the winter circle of stars around Orion. Let's start with Orion. We'll go up toward Taurus, where we found, again, Aldebaran and Mars. But we're going to come above Taurus to Auriga, right up here. Auriga has a very bright star called Capella. Capella is a yellowish white star that is very much like our own sun. So of any of the stars that we can see in the night sky easily, Capella is one that looks more like our sun than any other star, is more like our sun than any other star. Moving over a little bit to the east, we come to Gemini, the twins of the night sky, one of the zodiac constellations I mentioned. Of course, Taurus is the other zodiac constellation, and the two stars at the head, at the top of the twins, Pollux and Castor, are almost the same in brightness, so they're easily recognizable as well, and are just above the star Betelgeuse of Orion, the shoulder star of Orion right up here at the top. If we come down through and past Monoceros, before we come past, I'm sorry, as we do come past Monoceros, we'll see that there's a lone star right out here. The star is part of the constellation Canis Minor. Canis Minor. This is the little dog of Orion. Orion has two what are called hunting dogs that follow him around. Since he's Orion the Hunter, he has his hunting dogs. This star right here is called Canis Minor, right here. And if we come down a little bit further past Monoceros, and we skip over Monoceros because of the fact that it's a constellation with dim stars. But guess what? Monoceros is a really interesting mythological creature. Which one? It's a unicorn. Ready for that? A unicorn in the night sky. Let's go down below Monoceros where we come to Canis Major and the brightest star of the northern hemisphere sky, Sirius. Sirius right here is 8 light years away from Earth. 8 light years. But it's the brightest star in the northern hemisphere sky. And it's easy to recognize, of course, because it is the brightest star. So if you can find Sirius, you can easily find your way up to Orion with its 3 belt stars. And then you can continue a line on up to the red star Aldebaran in Taurus, and you will have found 3 of the constellations of the winter circle. All you have to do is go above the shoulder of Orion to reach Gemini. And then if you come back down and you go above the head of Orion, you can come to Capella right overhead here. And of course, you complete the circle coming back around to Taurus. So this is the winter circle of stars. And we're observing the sky at 8:45 in the evening. If we look a little bit over to the east, we'll find the constellation Leo the Lion. Leo is the main constellation of the spring sky. So to find Leo so high up in the eastern sky at this time tells us that spring is on the way. So what we're actually watching with the shift of constellations is not the stars themselves moving, but the Earth in its orbit around the sun. What's changing for us is the panoply of stars in our night sky background as we change position orbiting the sun. So that's how we can have different stars available to us or different constellations as we move through the season. As we orbit the sun, the night sky changes because we're looking out on a different group of stars as we orbit the sun. Okay, so that's what's available for us to see in the evening sky. What I'm going to do now is I'm going to send us forward in time, and I'm going to use my little timing device here over in the corner to take us forward in time an hour at a time. And the reason why is because I want to show you what's happening over in the morning sky just before sunrise. Now here we are at 5:47 a.m. I'm going to take us a little closer to 6 p.m. And the reason why is because I want you to see where these other constellations, where these other planets are that are visible. First of all, here's the last quarter moon down in the constellation Scorpius. Remember, we're just before 6 a.m. But over here in the southeast, we can see that Jupiter and Saturn are visible in this portion of the sky. But I want you to take note of something that's really important. Over here, we can begin to see the glow of sunrise. And if we just step time forward a little bit more, what happens is you'll notice that the sky is brightening. And as the sky brightens, these planets dim from view. So here's the challenge. The challenge is how much time is there between when these objects rise above the horizon and the sky becomes too bright for us to see. So in this particular window of time, there isn't very much opportunity for us to see Saturn and Jupiter at all right now. If we wait another month, these planets will have moved a bit further away from the sun so that in the pre-dawn hours, we'll be able to see them further away from the glare of the coming sunrise. So even though they're there right now, they will be very, very hard to see. Wait a month and we'll be able to see better. Okay, so you can see how we've been able to move the sky around so that we come to a different time of day. This is a very handy program to use. It works really well. I hope you use it, stellarium-web.org. It's a really cool one to use. Okay, so next we have two other things we have to hit really quickly here. I'm going to go back to the Mars 2020 Perseverance rover mission. And the reason why is because you can find all sorts of information about the mission if you simply go to the website that we have here, mars.nasa.gov, and you can come right to this site where you can find out all this really cool information. I'm going to back my screen up just one more page if I can. And the reason why is because here at this particular page, this major overview page, we can find out all the really great stuff we need to know. So we can see down here how long the rover has been on Mars so far. 14 Martian days, 11 hours, 52 minutes. And if we scan forward in just the opening page images, we can see some of the very first images of Perseverance down on the surface of Mars. I'm going to go one more forward because there's a really beautiful panoramic view from Jezero Crater showing what the surrounding area looks like. And one of the most exciting aspects about the mission so far is how the rover actually got down onto the surface. And in the video that you're seeing now, you're watching how the parachute deployed to allow the spacecraft to slow down as it came into the Martian atmosphere. You're seeing how the sky crane maneuver deployed the rover from the upper the rocket stage that then eased the rover down to the surface. And you can see the cables that let this down to the surface as it was just coming down to touchdown. So these are just brief snippets that you see on the opening page. But as you dig deeper into the website, you can find the full videos. You can find all of the newest images that are available. If we scroll down just a bit, we can come down and see the raw images of Mars this week. And so right here, I can go to the image of the week from the Perseverance rover, and we can look out and see what the surface of Mars looks like. And you can look at all of the images that are available so far. You can dig into this and learn as much as you want to know about what the mission and purpose of the rover is going to be on the planet. And if you come back week to week, you can keep track of what the rover is doing. So that's a really cool thing to do to check that out. So I wanted to make sure you knew about that. That's why I'm wearing my NASA shirt today in honor of what NASA's been able to do to drop this rover onto the surface. The next thing I want to mention is yesterday's SpaceX Starship test flight. Now, SpaceX has been running a series of test flights over the last 6 months or so, building up their capability to use this new spacecraft that they're developing called Starship. Starship is going to be much bigger than any other spacecraft we've ever seen, but what SpaceX has been doing is running test flights to see if the propulsion system is working properly. Well, yesterday, they ran their latest. That would be serial number 10 of these Starships in an effort to try to get the Starship to land upright for the first time. There have been several other attempts, I think 4 other attempts in which they tried to get it to land, but every time they brought it back down, every time it came back after its initial flight, it would crash at the landing site. So it's had it's actually 3 successful flights, take off, fly up to an altitude, then come back down and try to land. And in 3 instances, it's crash landed and exploded. In this particular instance from yesterday's test, the test flight went perfectly. Starship took off, flew up to an altitude, hovered there, tilted over to make its approach back down to Earth, straightened up to land vertically, and it landed vertically. Fabulous. That was exactly what the test engineers wanted to see. They wanted to know that they had the computer code put together properly so that it would land vertically, and it did. Well, the only thing is, about 8 minutes after it landed, the remaining propellant that was in the rocket exploded and blew the rocket up. Well, that's okay. Although they would rather not have that happen, they got through the test portion of the mission to prove what they needed to prove. So even though there was an explosion afterwards, they achieved all of the objectives of the test flight. So it was a successful day yesterday. So please keep that in mind when you're thinking about what happened yesterday and what SpaceX is doing. Now, the intention for SpaceX is that they want to use this rocket as the way to carry enormous amounts of payload into space. And this is in preparation for being able to establish research stations on the moon and eventually establish research stations on Mars. Now, this is the work that's being done by SpaceX, in some instances together with NASA, and in other instances on their own. But it seems like they have the capability to do this. So if you follow this program, you'll learn a lot about what's coming in the future. So the intention is that this spacecraft will be used as a major way to have access out to the moon and onto Mars. It's a really exciting program, and you can follow along. A really interesting thing that's happening is that the rapid method of development and testing that's being done by this independent group of SpaceX is collapsing the timeline for making it possible for us to get from the Earth back to the moon in the not too distant future. So keep track of that. You'll see what's going on. Okay, folks, we've had a really exciting evening so far. We've had a lot to talk about. We've had a lot to review. We have a few minutes left. Let's take some more questions if we can. I'm going to stop sharing my screen at this point so we can come back to here, and we'll see what other questions you have for us this evening. What do we have, Linda?
Ashley would like to know, which is better, Titan Dragonfly or Europa Clipper?
Oh, who was it again? It was Ashley. Ashley, Titan Dragonfly or Europa Clipper? Wow, that's a really great question. I'm not sure I have a favorite between the two because we'll learn so much from either one. We'll gain so much information. What'll happen is these places will become new places to us. I think Europa Clipper is the one that I'm really excited about because I want to learn more about Europa. I really do. Titan is interesting, no doubt, but I think I'll go with Europa Clipper. Thanks. Tell me which one you think you're most interested and excited about. Leave us a note in the chat. Thank you very much. What's next?
What is the most researched practical solution to prevent a collision with an asteroid?
Well, the question is, what's the most researched practical solution to avoid collision with an asteroid? Don't make the asteroid angry? No, that's not the one. So what's being looked at right now, there are a number of a number of ideas that have been put forth to redirect asteroids from colliding with Earth. And for a long time, a thought was that if we could somehow use explosives to blow the asteroid into bits, that would solve the problem. And what mathematics and modeling have worked out for us is that all that does really is create a larger field of items that are going that will pepper Earth once it arrives in this portion of space. But what has emerged out of these studies is that if we can learn about an asteroid that is on a collision course with Earth early enough, one thing we might be able to do is to simply redirect the asteroid not to hit Earth. How would we do that? A couple of ideas. One would be to send rocket craft out to the asteroid, have the rocket land on the surface, and then use its rocket motors to slowly redirect the asteroid to another spot on a different trajectory. Now, we need to know early enough because we don't need a lot of push, we need steady push. And even if it's just a small amount of energy that's being exerted over a long enough time, we can redirect the trajectory so that the asteroid can miss Earth. Another idea has been to use differential heating of the asteroid from the sun to help change its trajectory as well. And how would we accomplish that? Well, we could either use rockets to carry a payload of very, very light material to spread on the surface, or very dark material to spread on one portion of the asteroid, so that heating from the sun, that differential heating, would cause the asteroid to slowly adjust its trajectory, possibly away from Earth. So those are the ideas, the better ideas that exist right now. None of them, of course, include Bruce Willis going out with a load of explosives to blow the asteroid up. Thank goodness we don't need that. Just joking, of course. But hopefully we'll come up with some other means between now and then. Right now, we don't have anything to worry about. There are no large Earth-destroying asteroids on a collision course with us that we have been able to identify, and scientists are doing a really great job of taking inventory of the asteroids that are currently in space with trajectories anywhere near Earth, and have determined that for the time being, we're in a pretty safe spot. So we're good on that. What's next?
Our last question. Anna and Fran would like to know, stars at the edge of our galaxy travel at 1,500 kilometers a second. How come they don't just fly off?
And this was who again?
Anna and Fran.
Anna and Fran want to know why those stars that are zipping along at such a high rate of speed at the edge of our galaxy aren't flying off into space. Well, they, very simply put, they still don't have the escape velocity necessary to escape the gravitational pull of our galaxy. Now, if you think about it, these individual stars are moving at a very, very high rate of speed. That's pretty good. But if you balance that against the mass of the galaxy, then you might be able to more easily understand that even though they are moving that quickly, the mass of our galaxy is generating enough gravitational attraction to hold them in orbit around the center of our galaxy. What are we talking about in terms of mass? Well, our galaxy seems to have on the order of 350 to 400 billion stars. That's a lot of mass, not to mention all the rest of the gas and dust that's there. So with that mass, these stars are still hanging on as being part of our galaxy. There have been known to be stars that escape their galaxies and travel through intergalactic space, but not very often does that happen. So in the case of these stars, they're still hanging on with us. Well, that was our last question for the evening, folks. Thank you so very much for joining us tonight. I hope you had a great time. I hope you learned a lot. And I hope you'll take the opportunity to use the information that you've picked up this evening to give you a chance to go outside under the evening sky and enjoy the beauty of the universe. This is your chance to go out, look up, reconnect with the universe. And there's so much out there that you can learn, so much out there that you can see. You too can delve into astronomy in this manner in whatever aspect of astronomy you might want to get into, whether it's planets or stargazing or astrophotography, using a telescope, any of those things. But this gives you an opportunity to reconnect with the universe. Easy for you to do, no matter where you are, center city, rural, in the suburbs. There's something in the sky for everyone to observe. You know, the Franklin Institute is open now, Wednesdays through Sundays. We have this great exhibit, the Crayola exhibit, that we'd love to invite you to come to. It's not what you think. You might think it's about crayons, but it's about way more than that. Crayons almost don't even enter the picture, but come check it out. We're excited to offer you this modified museum experience that's designed to celebrate science in a safe and welcoming environment. We are following all of the COVID-19 protocols that allow us to provide this safe experience for you. So please come down and see Crayola, the exhibit. We ask you, though, to get advance tickets online. Go to our website, get those tickets in advance. And so there are no online fees, of course. So you can be assured of getting a place when you come to the Franklin Institute. Don't forget, masks are required, and we are practicing enhanced cleaning protocols. You can visit our website at fi.edu to learn more and to reserve your tickets. Don't forget to check out our other Franklin at Home programs at fi.edu. Again, you can follow me on Twitter at CoolAstronomer for daily updates. Please stay safe. Don't forget, wear a mask, wash your hands, maintain that social distancing until we can get all of this pandemic under control. It's going to take us a while to do that yet still, so we need you to stay with us as we're doing that. Thanks for joining us this evening. Enjoy the month of March. Spring is coming. It's on the 20th. But we'll see you in April. Thanks for joining us, folks. We'll see you next time.